So I'm going to explain very important part about the periodic trend, and it is the metallic and non-metallic character. This is very important part, how metallic character and non-metallic character varies in a periodic table. So metallic and non-metallic character. So the trends in the periods, trends and groups. So on moving from top to bottom, in a group, the atomic size increases. On moving from top to bottom in a group, the atomic size increases. And why increases? Because of new cell is added and the electrons are loosely bonded by the nucleus. So first I am coming to metallic character. So first in groups. So on moving from top to bottom in a group, metallic character increases. So it increases down the group. It increases down the group as the electrons in valence cell are bonded by poor forces. So on moving from top to bottom, the metallic character increases. What are metals? Metals are electropositive in nature. So why electropositive in nature? Because electrons are bonded by poor force of attraction, and so electrons are lost easily. What are metals? We say that metals are electropositive in nature. So electropositive nature means tendency to lose electrons. Why metals lose electrons easily? Because the electrons, valence cell electrons, are bonded by the poor force of attraction. So this is one point. That on moving from top to bottom, the metallic character increases down the group because electrons are weakly bonded. Now, second, in periods. So what happens in periods? In a period when you move from left to right, atomic size decreases. So what happens? Electrons are strongly bonded, and metals exhibit reactivity by the loss of electrons. Non-metal exhibit reactivity by the gain of electrons. So it will be in period just opposite. So it decreases. It decreases from left to right in a group as the electrons or valence electrons are bonded strongly. So electrons are bonded strongly, so electrons cannot be lost easily. So that's why it will be easier for a non-metal to exhibit reactivity by the gain of electrons. So there is the just opposite in the case of non-metals and metals. So if we draw graphically, so here in group ornaments, it increases, metallic character increases down the group. Now in period, it decreases from left to right. So this is about the metallic character. Now coming to non-metallic character. So you know, non-metallic character will be just opposite. So non-metallic character will be just opposite to that of the metallic character. So what we can say? First we'll say in period. So in periods what happens? When we move from left to right, atomic size decreases. Atomic size decreases as electrons are strongly bonded. Electrons are strongly bonded. Electrons are strongly bonded, and so what happens? Non-metallic character increases. Thus, non-metallic character increases. So this is the point, non-metallic character increases. So this is in case of period. So in the extreme left there are the metals, extreme right there are the non-metals. Now second, in groups, non-metallic character decreases. Non-metallic character decreases from top to bottom. Non-metallic character decreases from top to bottom as electrons are bonded by the very poor force of attraction. So actually metallic character increases. So metallic character and non-metallic character, they are just opposite to each other in case of all the points. So this is the general representation about the metallic and non-metallic character in groups and period. See, the metals in this trend is in case of metals as well as non-metals. So on moving from top to bottom, metallic character increases because the electrons are bound by poor force of attraction. So on going from bottom to top, non-metallic character increases. Why? Because size is the key factor. So size, on moving from bottom to top, atomic size decreases. So metallic is there, but they are less metal. What we can say? Elements at the top in any group, they are less metallic. At the bottom, they are more metallic. Similarly, in case of in a period, on move from left to right, non-metallic character increases. Non-metallic character increases because non-metals are found toward the right of the periodic table. Here, on move from this, metallic character increases, and this is the general trend. This is the general trend. Like in case of group 17, I am taking halogen family, group 17. Group 17 is halogen family, halogens. So this group 17, so fluorine, bromine, iodine. Just I have written. So fluorine is a gas. Fluorine is a gas. It is colorless. It is colorless. Then it is a greenish yellow. It is liquid orange color. it is solid, it is black, brown color. Now see, there is transition in the state. The state transition takes place. What happens? Fluorine is the gas, chlorine is the gas, bromine is liquid, oxygen is solid. See, colorless. Fluorine is colorless gas. It is greenish yellow gas. It is orange. It is black brown. What is clear? Clear is that gas to solid. So metals are solid. So what we can say, iodine is metallic in appearance, metallic in character. They are all non-metals. All non-metals. They are all non-metals. They are essentially non-metals. But iodine has metallic character. Iodine has metallic character. Number one, it is solid. It is solid. Number two, it has luster. If you take the solid piece of iodine, so it has little amount of luster. So it has luster. So this is about the metallic and non-metallic character. And it is due to the size, atomic radius. It decides the metallic and non-metallic character. Now I'm going to explain about the reaction between metals and non-metals. So metals and non-metals, they react together, and there is a measure of ionic compound. So ionic compounds are formed only by the reaction between metals and non-metals. So here I have taken calcium and chlorine. Calcium is a metal. So calcium atomic number 20. We write down the electronic configuration 2, 8, 8 and 2. So here the valency is 2. Last orbit, last cell has 2 electrons. So calcium will lose 2 electrons, and there is formation of calcium cation. 2 electrons are lost. So it is oxidation, loss of electron. Now chlorine is a non-metal. So chlorine atomic number 17, configuration 2, 8 and 7. So it will gain 1 electron. One atom will gain 1 electron. There is formation of chloride ion. And here 1 electron is gained, so atomic number will increase by 1. So it will be 18, 2, 8 and 8. Now see, calcium cation. Calcium cation has been formed by the loss of electron, and it has acquired the noble gas configuration equal to what? Equal to argon. Similarly, it has also required electronic configuration of what? Argon. So here it has 2 positive, here it has 1. So we'll balance the equation and we'll multiply by 2 to equalize the charges. And so here the electrons are cancelled, and so this will be there. And so thus ionic compounds are formed by reaction between metal and non-metal. Ionic compounds, they are water soluble, they are crystalline in nature, they have high melting point, they have high boiling point, etc. So these are the very important points related to periodic properties, periodic classification, etc.